Hello everyone, today I'm going to share you some knowledge about lithium. Lithium is a silver-white alkaline metal. Let's take out a piece of lithium and see some of its properties. It's very soft. We can cut it easily with a knife. Its most hardness is 0.4, a little harder than sodium, which is 0.5. Like other alkaline metals, lithium is also very active. When we put a lithium, which still exhibits a metallic luster, into the air and observe it, we found that it will completely turn black-gray in 10 minutes. Unlike other active metals, the oxidation of lithium is carried out with nitrogen. Because it's very active, its reactivity is serious, even ranked first. By the way, when we use liquid paraffin to preserve lithium, we found lithium floating in it. This is because the density of lithium is only 0.534 grams per cubic centimeter. It's a reaction of lithium and water. We first draw phyllocyanine into the water so that we can test the product of the reaction. Pretty cool! Our lithium swells and bubbles out. The solution turns red. It proves the alkalinity of the product. Of course, that is lithium hydroxide. When we ignite these gases, they start to burn. Because there is not many hydrogen gas, we can also hear the explosive sound because of mixing of oxygen and hydrogen. Red flames can be seen as lithium's flame test. By the way, the heat released by the reaction is not very high, not even enough to melt the lithium. Let's look at the burning of lithium in the air. Heating 2 lithium blocks in a crucible is a bit too much. I actually regret it. Lithium begins to melt and produces white smoke. Later, it began to burn with a red flame. The temperature was so high and my camera could no longer see it. I suspect that I used the cribble is not correct, because the high temperature even caused the cracking of the ceramic. By the way, the lithium burning produced some solid with a cauliflower-like morphology, so it's worth to show, but I haven't recorded it. So far, you know the basic properties of lithium. Now, what you are going to see is the reaction of lithium with acid. We have prepared concentrated hydrochloric acid and sulfuric acid. In the next video, we will show reaction with nitric acid and hydrogen peroxide. Lithium seems to react more intensely with hydrochloric acid than with water. In practice, it will be observed to see hydrochloric acid fog over the beaker. That's really nasty, so I suggest you to do this in a fume hood. Well, now is the reaction of sulfuric acid with lithium. At first, the reaction was not very intense, only some bubbles were formed. Later, enough heat was released, and it started to make lithium burn. With the smell of sulfur dioxide, the bottom of my beaker cracked. Now, the house is full of hydrochloric acid fog and sulfur dioxide. I need to get out and do more experiments next time. It will be very effective to watch this active metal burning in lots of reductive gases.